Great. All right. Hello, everybody. My name is Nick Klosky, and I am one of the co-founders of Honeypoint 3D. I welcome you to the December 2015 Meshmixer webinar from our Kickstarter. This is a special invitation to everybody out there. This is open to the general public for December. This is one of the monthly webinars that we gave as one of the rewards in our Kickstarter that we ran 4 or 5 months ago. So welcome all of the new people. We actually have quite a few people that are not Kickstarter backers in this call, so I welcome you. Just to kind of give you an overview of what we're going to be talking about in this webinar is Meshmixer. Certainly a lot of techniques that people have sent in on the survey requests, and I'll go over all of those questions. Some other kind of Meshmixer related things about the new Autodesk Software Print Studio, which is very Meshmixer-y. A lot of features in there to help you 3D print correctly. And then some of you sent in some questions on other things that are just about 3D printing. So some logistics. There is a chat, kind of a chat box, hopefully in the right-hand side of your screen, and that is something where you can ask any question you want. I'll say this in every single webinar that we do. I really want you to ask questions. I certainly have the things that I have found interesting over the last month about Meshmixer and 3D printing, but I really, really want to answer your questions on just really anything with 3D printing. So to get started, without any other further ado, I'll go to some of the questions that we got in our surveys. The first question was actually not about Meshmixer at all, but it was about the Carbon 3D printer, which is a really kind of neat technology that Autodesk, the Spark Fund inside of Autodesk, invested in. So Autodesk announced the Spark Fund that is quite a bit of money, I think $100 million or so, to invest in various 3D printing companies in the world, or 3D printing and 3D design. So Autodesk invested in the Carbon 3D printer. If you look at the two different types of printers on the market, one is called FDM, Fused Deposition Modeling, which uses a strand of filament into the printer to essentially melt it like a hot glue gun, except very accurately. The other side of that is called resin printer, is also called stereolithography. Stereo for eyes or light, and litho for writing. Essentially, you're writing with light. And the resin printers, one of the problems with that is that the liquid resin gets cured by a light on a build plate with usually a light shining upwards. The light, either a laser or a projected image, cures the resin at the very bottom, and then the build plate moves up and it does it again. So over time, your object is being pulled out of a vat of liquid resin. The problem with that, or not the problem, but just one of the ways that happens with that, is that the resin, since it's, gravity is affecting it, it gets stuck to the bottom of the build plate. And so after a layer has been drawn, inscribed with light, there's a kind of a ripping mechanism that kind of rips the resin off of the vat, pulls it up, and then pushes it down, and then it traces another layer, and then it rips it off again. And so you'll see this kind of ripping mechanism where it has to detach from the bottom of the plate. The Carbon 3D printer is very different. It uses a layer of, there's all these proprietary techniques inside of here, but the basic thing is that the Carbon 3D printer doesn't have to do any sort of ripping. It just slowly pulls the model out without having to do this up-down ripping. It uses some sort of oxygen permeable layer that's kind of like a resin curing zone where it's just curing as it's pulling out. So it doesn't have to do the ripping, which is what makes it so much faster, because the ripping mechanism can add 1 or 2 or 3 or 5 seconds to every layer, which can really add up. Now, I don't know anything about the actual detail level of the Carbon 3D printer. I haven't done much research on it. I don't know if they've actually put out information on that, because as you're tracing this, you can be very precise when you are, shining light on one layer and having it move up and move down in another layer. I don't know about the resolution for the Carbon 3D printer. Hopefully it's good. It'll help kind of change the landscape for resin printing, but we'll see. So somebody asked about the Carbon 3D printer, and that's kind of all I know about that. So we got a question from Thomas. Where do we go to review the previous webinars? So if you're a Kickstarter backer, you have access to, and you got the level for all of the previous webinars. If you don't have those emails, you can just or if you don't have those addresses, you can always email me, and I will send you a link to all of the previous webinar links. I should really create a web page with all of those on it. If you're not a Kickstarter backer, then still email me. I can see if I can open those up to you, or if you have specific questions, I can see if I can answer those. All of this is based on the Udemy course that we have on udemy.com, which is the Meshmixer and Intro to 3D Printing classes. So, the Meshmixer class is about 16 or 17 hours. The Intro to 3D Printing class is, I think, 4 or 5 hours, something like that, of all do it at your own pace videos. And so that's kind of like the star of the show here. The webinars are just to kind of keep people interested month to month and talk about interesting things. So we had a couple of questions. I'm looking here on my list. We had one question about cleaning up of scans. So I have an entire section on this in the Meshmixer course, but this question came from one of the people that didn't purchase the course. So I'd be happy to kind of go over the rough process of how you do a scan cleanup and prepare that model for 3D printing at a service bureau, specifically probably at a service bureau, and I'll show you why. So let me start sharing my screen, and I will show you some scan cleanup. Just a few minutes. It's actually pretty quick to do most scan cleanups. So let me share my screen here. You'll see the webinar going into infinity, but I will bring up Meshmixer right here. And there we go. So this is a Meshmixer. I'm going to go in and import a mesh. So I think I use this one in this example in the Udemy videos, but this is a scan I created with 123D Catch, which is my cell phone, essentially taking pictures with any camera you happen to have that will create a 3D model. So if I click, the mesh gets imported without any shaders right here, but if I click on shaders and drag the little world icon on, we'll see what this is. This is actually my kitchen. Chairs and tables. There's a window out over here looking outside, all this stuff. But what I wanted to get was right here in the center, which is a rock. So this is a rock from my garden that I wanted to scan. So if I turn on wireframe by hitting W, you can see that it's okay. It's actually not as detailed as you might think. If I turn the shader off just to a normal shader, you can see that there's not that much detail on the rock. Certainly more than I could have created by myself, but not, a terrible amount of detail. But it's all relative. If you wanted to try to model this rock by hand, it would be super difficult to get it accurate. So this is still a really, really good start. If I hit W again, go back into wireframe, you can see that 123D Catch doesn't put a whole lot of triangles. Let me select some up here. This doesn't put a whole lot of detail in large flat areas. So you can see up here the triangles are pretty large. But in places where there's a lot of curvature, like down here, you can see that there's a lot smaller triangles. So the software says, there's a little bit more detail there. I'm going to spend a little bit more time making it accurate in these areas. So that's why there's a difference. Now, if we go back and turn the shader on by dragging the little world onto it, you can see that it looks really, really detailed if the color is turned on. But that is kind of a deceiving thing because the color, like you might think that there's a lot of information right here in the center where this little divot is, but if I turn wireframe on, there's a little bit of detail there, but not a whole lot, you know, and especially down here where you get all these patterns in the color, but the actual mesh doesn't have a lot of detail. With that said, if you were to go 3D print this in color from an online service bureau, a lot of these colors would come out. They wouldn't be represented by geometry underneath, but the colors would come out. So that is a kind of a cool thing. So a basic scan cleanup, if I zoom out, you know, this is everything that was captured by 123D Catch, a lot of stuff that I don't want. So this is a very good example where I was able to go completely around an object. And this is like a little cutting mat that I photographed this on. I was able to go completely around. Oh, and by the way, here's something that you use a lot. You know, if I try to zoom in on this rock, I'm not really zooming in on the right place. So then I might try to pan it over. That's great. And I zoom in. But when I start turning, I'm turning like not at the right aspect. So a shortcut that I use all the time is the C key, C for center. So wherever your mouse is, if you press the C key, your camera will be centered on that. So I'm centered on that cabinet here. If I happen to have the rock way at the corner of my screen and I press C, the rock now jumps to the center of the screen. So you end up using that a lot. Even if you zoom in like this and you say, oh, I want to center on this area down here, you don't really have to move the mouse and go like this because you're not really rotating around this divot right here. You're rotating around somewhere else. So you hit the C key and now you're rotating around that divot. It's terribly, terribly useful. Okay. So let me go back and say you really want to just get rid of a lot of stuff when you create a scan. So the easiest way to do that is to go to Edit to Plane Cut. So Plane Cut creates a plane that's going to be cut on. And you know, you can manipulate that plane with these little handlebars here. Let me zoom in a little bit. These little handlebars here, you know, rotate it in different ways like this, or move it with the arrows. Move it like this. And you can see with the arrows, you know, when it gets shaded or ghostly, that's what's going to get cut away and the actual model stays. But what's kind of easier for something like this is even if you see the rock like this, you can just drag a line. So I'm going to click and drag a line right at the bottom of this rock. Boop. And it creates a plane right here. Now, sometimes it might show up like this, and you say, hey, I dragged a line and it's not cutting the right thing, right? It's going to keep the counter and get rid of the rock. This little blue arrow pointing upwards changes the orientation, upwards and downwards. So now if I click on this, the rock gets deleted. If I click on this, everything else gets deleted. I'm going to click Accept. So great, but that cut also left some other things here, right? It wasn't, it was great for the rock, but not perfect for all of the rest of the stuff. So that's actually very easily fixed. I'm going to go up here to Select on the left-hand side, and this allows me, you know, to select, you know, so you see I'm selecting little things like this, but there's actually an easier way. I'm going to select and just kind of draw a line around the thing that I want. So in this case, it's selected it, but I don't want that to be selected. I want everything else because I want to delete it. So I can go up here to Modify to Invert, or just press the I key. And now everything except the rock is selected, and I can hit the Delete key. Boop. So now I only have the rock left. And the plane cut has created a nice cut on the bottom. And I could 3D print this. Now, the question that was asked online was, how do I hollow things? Well, if you upload this to Sculpteo or Shapeways, or specifically Sculpteo, I know this, but I think Shapeways does this as well. You can add in holes and it will hollow the model in the online program. You don't have to do it in Meshmixer. And it will, and the reason why you would want to hollow it is otherwise you would have to pay for all of that material that's inside that rock. And sometimes that can get really expensive when you just want the outside. You just want it to look like a rock and not feel like one. And so those tools online, actually, Sculpteo and Shapeways have little things that say hollow and place holes in to make it hollow. But if you want to hollow this yourself, here is how you would do it. Now, first off, you need to make sure that this rock is the size that you want. So if you click on Analysis to Dimensions up here, you can see that right now, this rock is showing as 6 millimeters tall. That's pretty darn small. So this did not come in the right way. In fact, this rock was about 6 inches tall. So for some reason, this 123D Catch, I guess, worked in inches, and then when it came into Meshmixer, it switched it to millimeters. So what we end up doing quite a lot when we work with different measurement units is we go up here to units dimensions. Remember, we got to this for analysis, units and dimensions, and we see that this is 6.2 units high. Right now it's millimeters. That's not good. So we switch this 6.2 from millimeters to inches, and it brings up a little window right here. It asks if you want to keep or convert. Well, we don't want to convert 6 millimeters into inches because that would be super duper. It would be essentially the same size, but now notated in inches. So if we do this, it'll turn it into 0.0000 something inches. We don't want that. But if we say keep XYZ the same, you'll see up here that nothing really changed, but now this rock is switched from 6 millimeters tall to 6 inches tall. So that's great. It is now kind of correct height. Just because I like to work in metric, I'm going to go switch this back. And if I want to see how much this might cost in Sculpteo, I'm going to switch this to centimeters. And this time, instead of saying keep it, because I don't want it to turn into 6 centimeters tall, I'm going to go to convert. So the 6 inches tall gets converted to 15.76 centimeters tall, which is totally fine. It's just a different way of converting. And I'll tell you why I needed to do this. So if this were just on the, let me stop sharing just for a second and go back here. If this were only ever going to be on the computer, it doesn't really matter how big it is. It could be 6 millimeters tall. It could be 6 centimeters tall. It could be 6 whatever's tall. But if you are interfacing into the physical world, then obviously real dimensions are good. So we switched it to 6 inches tall, and just because I like to be in metric, I converted it into centimeters. But you could convert it into millimeters. That's just fine. So now the next thing we're going to do is hollow it and put in some holes. So let me go back and share my screen here. Share this back. Okay, so we're back at the rock here. There's actually just one tool inside of here. We go up to Edit, to Hollow right here. I click that. So Meshmixer will think about it for a moment, like this. And now you'll see, let me zoom in a bit here. So this kind of ghostly shape on the outside is the outside of your model. So that's not going to change. But you can see kind of this pink inner sphere or inner shape, and that is the new inside skin of the model. So if we look up here, right now the offset distance is 0.2 centimeters. And actually, I'm going to show you a different thing. So because I set the measurement to centimeters, everything is showing in centimeters. So I'm actually not going to do that. I'm going to go back into analysis to units, dimensions, and I'm going to change this to millimeters. And I'm going to convert centimeters to millimeters. So now 115 centimeters turned into 157 millimeters. So now it's a lot easier for me. I go into Edit to Hollow. Meshmixer will think about it a second. And the reason why you would do this is to save money, obviously. But right here, this offset distance is 2 millimeters. So what that means is it's going to create a 2 millimeter thick skin around kind of the empty space on the inside. Now, if you're printing with some materials from, like colored sandstone or something like that, it's probably good. They may say, your minimum distance is, a certain number. Actually, let me start over. If this were going to be, cast in metal, they might want to have, I think 1.8 millimeter skin. That's kind of pushing it, right? So this 2 millimeter is very, very close to the minimum required thickness from the printer. So I'm going to change this to 3 millimeters and press Enter. And I'm going to say Update, Hollow. And then Meshmixer will think about it a sec. And once it comes back, you'll see that this skin inside will kind of crunch inwards a little bit. There we go. So we have a 3 millimeter skin. I'm going to go to the bottom here. We have Generate Holes. I'm going to click on Generate Holes, and it will create 2 little holes right there. These little red buttons, you can drag wherever you want. So I'm going to just kind of drag one here and drag one here. And the hole, I'm going to make it a little bit bigger, maybe a 3 millimeter hole, and press Enter, and you can see that the holes got bigger, and then say Accept. Meshmixer will think about it for a second, and now we have a rock with some holes inside. And if we kind of click on this, we can kind of see that there's stuff going on inside. I'm going to do something very egregious here and do another plane cut right across the top side of this and accept it. And you can see that we created 2 holes down here to an empty hollow. And that's what you would do. You would upload, if I undo that, you would upload this into, Shapeways or whatever and get it successfully printed. So that is how to do some scan cleanup. Now, people wanted to know about some measurement tools. There's some pretty cool things inside of Meshmixer under Analysis, under Measure, right here. So there's Type and Direction. Direction, this is, absolute X, Y, Z. I don't tend to use this. I tend to use just the N, which is just based on the model itself. This first one is interior thickness. So if I'm clicking on this, you can, let me actually turn off the shader for a moment. Zoom in here. And you can see that there's a little red dot following me. And as I click and hold my mouse button down, you can see on the right hand of the screen right here, 3.08449. And as I click around, this is 2.99863. So it's showing that the thickness from this skin to the next skin on the inside is pretty consistent with the thickness of the skin that I just created. This number right here at the top is the maximum number since I started dragging. And this is the minimum number since I started dragging. If you let go of your mouse and you click again, those numbers will reset, but it helps to kind of show you that in this area, let's go like right here. If I click and drag and just kind of like scribble around and move the rock here, that area, based on where I kind of scribbled around, variates between 3.02 millimeters and 2.85 millimeters. And then right in the last place I clicked was 2.99. So it kind of helps you to determine thickness there. A lot of other different measurement tools you can do that are really kind of awesome, actually. And, different places, all the way through your model, 145 millimeters, things like that. Some very cool tools are distance. So it may not look like I'm doing anything, but if I hold down Control and click on one place, or Command on a Mac right here, and now I click on another place, I can get the distance between those 2 points through the model, which is pretty nice. So if I wanted to start my ray over here, I would have to hold down Command on the Mac or Control on the PC, click here, and now I can start dragging from other places. So that's some cool measurement tools there. Let me go back here. So that's some questions on the measurement tools and scan cleanup. So hopefully that helped answer those survey questions there. I want to get into another couple things, and I see there were some questions on here. Do I have any other Kickstarter classes in the works? Not to be launched on Kickstarter probably, but I am working on kind of an inventors class where it's not specifically about any specific program, right? If you walk up to a person on the street and you say, hey, I want to teach you how to use Meshmixer, they really don't know what you're talking about. But if you walk up to them and say, hey, I want to teach you how you can be a product designer, right? They totally know what you're talking about. The product design class will use elements of, the one that I'm creating will use elements of Meshmixer, Tinkercad, right, to start people off in CAD design, but then the main tools will be Meshmixer and Fusion 360. So I am working on that one. I don't have it out yet, but that is what I'm working on. Question, how about classes about NetFab? And that question is from Lewis. If you could put in the chat what you mean by that, I would be interested to I could certainly talk to that. NetFab, the way that most people interact with NetFab is just kind of repairing tools to fix disconnected shells and things like that. You can do all of that with Meshmixer and some other kind of cool things with Meshmixer. So if you're talking about just specific repairing things, I cover that a bit in Meshmixer. But if you want to type in the chat, maybe a more specific question about NetFab, I could help to identify that. And then Bill asked a question that he finds from last tool position option to be unpredictable. How can you best use it? I'll have to put that into another Meshmixer video. I don't use that very often because I too have not found it to be that predictable as well. This is in actually a number of tools where it's from last. It's called from last tool, where you're using positions like the pivots and some other transform operations. I haven't found too much of a use for it either. I know there are some, but I'll do some research and I can put that in the next video. So apologies for that because I don't really use that. But there were a few people that did ask about alignment. Now I'll say a couple things. I can't say officially that I know anything about the next version of Meshmixer when it might come out. But if I happen to know about it, I know that there are some really cool things coming out that will help in the alignment area. So I'm going to show you how to do some alignment type things now that were actually from MagWeb on the Meshmixer forum. But this process is going to get a lot easier in the future. So bear with it now and it'll get a lot better. So let me go back and share my screen here, off into infinity and go back. Okay, so what I'm going to do is go back on my desktop here and import this. So this is just a plate that I created. It's not flat on the bottom, kind of bumpy on top. So that's great. Let's import another plate and append it. And oftentimes what people see is that things come in, especially with scans, not aligned. Let me move the browser over here. And the question is, how do we align these things together? Now, certainly you can do it by eye, right? The way to do it is actually a kind of more official way is hold down spacebar and turn on. The little tip here is anything that is shaded is the thing that is enabled. So right now we want to make free not enabled. We don't want a free camera, and we do want to enable snapping like that. So what this does is it kind of clicks into the different views, like click, now I'm looking directly from the top. So I can see, if I click from the side, I see that this one on the left is pretty, seems to be okay, pretty aligned like this, but this one isn't, right? So I'm going to click on this, hit the T for transform, and try to kind of align it as best I can, and click accept. Now we go and let it snap to the other orientation. Again, hit T and try to align it as best we can there. And then we're going to go upwards and snap like this and try to align as best we can here. And then hope that when we put it on here, it kind of matches. But it didn't, right? So now we have to go back, move down, and we can see that these plates are really not aligned yet, right? So it creates a lot more work to try to put these, and then you don't really know if they're that aligned. Still, it's not. So here's a different kind of way of doing this. And I'm going to, just do some other different things like that. So the trick for this is usually the things that you want to align have some common features on them. So in this, let me do some selections. Make my select a little bit bigger here. I can see that this bump right here is common over here, maybe something right here, and maybe something right here. There's a whole bunch of other stuff going on this plate that's not aligned or not on the other plate, but those are something that is, somewhat similar from plate to plate. So what I'm going to do is do this a little bit more methodically. I'm going to go in and say this ridge right here is something I can find on the other one. This is something I can find on the other one. And I'm going to say something like this is going to find on the other one. So I've created 3 selections. And I can turn the snapping off like this. So I've created 3 selections. And now with these 3, I'm going to go in to edit to fit primitive. So create some things. This is set to square right now, so I'm creating some little squares. But what I want to click is say single primitive. Boom. So what it does is it averages all 3 of those things, those 3 selections, and puts a flat square in between those 3, connecting those 3 places. So I click accept. So now we have this very, very flat square in here. So what we're going to do now is go to edit to align. And I'm going to make sure that I have surface point and then Y up. And you see that the thing like went somewhere. I'm going to click on this plate, and you can see that the flat areas of this plate are not causing the object to flip. And you can see that the plate is under here. If you can also say flip like this if you want the plate to be like this. But see, the plate is, once I get over some little bumps that were poking up through that plate, that's not good. So I'm just kind of try to choose one of the flat parts of that plate and click accept. So now let me move this guy away. So now this plate right here, or this is aligned to the Y up. So this is facing directly upwards. I'm going to do align again. Oops, I'm going to make sure this one is selected and do align again. And instead of surface point, I'm just going to say base point and just translate. So I don't want it to rotate. And so that now put this facing upwards and the base point, if we view grid, right on the grid like that. So that's great. If you want, at this point, for ease, I'm just going to double click on this. Since it's its own face group, I can double click on it and hit delete. So I've gotten rid of that plate. So now I'm going to go over to the other object right here and try to select the same places. Now this won't be perfect, but it was generally right about here, generally around here, and generally right here. I'm going to do the same thing. Edit, fit primitive, single primitive. So we created a plate here. Click accept and edit to align. Thomas email just actually wrote in there. He says he has to sleep. It's 4 a.m. in his time. So I super appreciate Thomas's diligence for coming to this webinar. Thank you so much, Thomas, and have a good sleep. So I'm going to align again with the surface point selected and flip again. And see, as I click on this, there's some alignment happening. So that's pretty good. And then align again and switch surface to base point. So these two planes are essentially at the same level. Now, assuming that I was pretty good at selecting those two places, I'm going to select that and delete it. So now all I will need to do is use the transform tool in one plane, right? This green plane right here, to go and move it. And you can see I was a little bit off in my selections right here, but I only have to use these kind of little bit easier alignment tools of the arrows to get it where I need to go. Rather than, it looks like I was, quite a bit off on these, but you can see that it's getting a lot closer than if I were to try to eyeball it. So you can use these kind of helper planes to see the differences between these, and these plates were significantly changed right here. But it's actually a pretty cool technique to use those helper planes. And then once you have them aligned, you can do some of the measurement tools by selecting both of these and going into analysis here and doing things like deviation, where you can see how each one deviates from the other. And if you actually click on this bubble, you can actually select where it deviates, which is pretty cool. And it does depend on which order you click. If I click on the object, this first object here, and then the second, and do deviation, it'll show the deviation between the first and the second in that order. Or if I click on the second one first and then the first one second and do deviation, it shows the opposite. So it does matter the order in which you click on. And there's actually going to be some more, or other tools too. The clearance tools, how much clearance you have, between the two, that type of thing. A lot of cool things there. So that's how to do some kind of alignment type things inside of Meshmixer. Let me go back here so you can see me. So using that helper plane is very nice, because when you create the fit primitive command, it creates a plane with its own face group. So it's very easy to go and select that plane. It doesn't Boolean it in. It doesn't mess up your mesh. It just kind of passes through your mesh, but it's tied to it. So as that plane rotates, your other object rotates as well. As I said, for those of you, and it's actually quite an often request to do precise alignments. That will get better. I am absolutely sure of it. That's one way of doing it now, and it will get better in the future. Now, the last thing that I wanted to talk about of the things that I sent out in the email was not really with Meshmixer, but it does interface with it. If I go back into share this, go back into Meshmixer and just bring in the bunny, replace and fix the bunny here with the inspector like this. You know that that Meshmixer creates overhangs. So we go here to analysis, generate supports, right? So very, very blocky supports. These are supports for an FDM printer called an Ultimaker. These are supports for some sort of SLA printer, so a resin printer. Since these print upside down, you'll see that there is it's essentially, let me do a free camera. You could essentially see that this prints upside down like this. So there's a huge amount of platform right here, and then it prints downwards like that. But it creates support structures. And let me switch this back to Ultimaker, remove, generate. And when you're done with creating supports, right, you remember that you can edit supports inside of here. You go to convert to solid. You can create a new object or replace existing. I'll just replace existing. And now you have some models. If you hit wireframe, you can see that these are 3D models just like the bunny is. And before actually I go into Print Studio, I want to tell you one other thing that I thought was really, really awesome. I'm going to go back out. I'm going to go back into overhangs. Now, a lot of people say, I want to generate support. Great, this created support, but I don't like this support, right? So they'll say, I want this support not to be attached to the foot of the bunny. I want it to be on the ground. Why isn't it doing that? Well, there's a couple of different things you can do that are completely hidden features inside of Meshmixer. If you press the D key, D as in David, or D for display, or D for debug, you get some really awesome effects. Haha. So this is kind of a hidden Meshmixer tool that shows you all of the places that Meshmixer thinks are valid for creating automated supports. So if there was some object up here, the entire back of the bunny would be fine for creating automated supports. But you see that down here, Meshmixer doesn't like this for some reason. If you change the settings, the automated support settings also change. You can see that when we create support, it will create them from these little, center on this, these little blue dots right here, downwards, right? And the red is overhang dots, going down wherever they need to go. Now, a lot of people say, okay, well, this is great. This helps me understand where Meshmixer wants to create support structures. But what if I want to create a support structure and Meshmixer doesn't let me, right? So right now I can drag down. There's something about this support that Meshmixer doesn't like. If I just click, right, if I just click the mouse, I can start creating supports. But if I click here, you see Meshmixer doesn't let me. If I drag it down, Meshmixer doesn't let me for some reason. It violates one of the rules up here. So what if I want to say, I just want to create a support down, right? So the way that I did that is I held down the Shift button. So holding down the Shift button says, don't listen to any rules, just create the support wherever you as the user tell it. So if I go like this, I'm going to create a support. But I did something, you have to be very careful when you use this, because you can see that that support carves through the bunny. So I could create a support like that literally carves through the bunny. So you have to be very careful when you use the Shift key, because you can create supports that there's no way they could exist in real life. So like that one's fine. I'm just clicking, clicking, clicking. Great, it's all working. But if I know that I want to support somewhere else, like right here, for example, I could try to kind of fudge it and have it go down, or I just hold down Shift and it will create it. But remember, it can mess up your model. So that Shift key is really, really cool. And the D key is kind of useful too, to show you where Meshmixer thinks that automated supports can go. So some people do ask about that. And so people also say, great, I'm going to remove all of these. Let me go back into Ultimaker, generate support, turn off that. Convert to solid. So this is what I would export for printing. But then, sometimes, the printer needs to make some it wants more supports in a certain place or whatever. So this is great, but, sometimes you just maybe want a little bit more, or your slicer might tell you something more. So let me go out. Let me export this as bunny.stl on my desktop. My desktop right here, bunny, and bring up a slicer that I have called Simplify 3D. Right. So the bunny comes in here. I can say customize support structures. I believe this is at the same angle, and generate supports. And you see my slicer actually has some more supports that it suggests over and above what Meshmixer wanted. So Autodesk also realizes that people want to actually print. So I'm going to bring up the new software from Autodesk called Print Studio. This is Autodesk Print Studio, and you'll see some really interesting things. So let me go back and just export the bunny just by itself. So now we have here, let me make Print Studio a little bit larger. So I'm going to import something. I'm going to go to the bunny and bring the bunny in. So this is essentially a slicer. This is the software they use for Autodesk's Ember resin printer, but it can also create toolpaths for FDM printers. So this is the bed of my printer. This is a Type A Machine Series 1 printer, an FDM printer, and here is the bunny on it, right? So I can say rotate it on the print bed, maybe move it if I want to. And this is kind of a progression up here: import, layout, repair, supports, preview, and export. So right here we say move. I'm going to center it on the bed. I can move it to a bed. I can say auto layout and maybe see what it thinks. It thinks, not too much. I can do some scaling of it if I want, make it a little bit bigger. I can lay it flat. So it's trying to figure out ways of laying it flat. So this is kind of nice. If these little, look like little guitar picks, you can click on one of these and it lets you orient your model based on some suggestions on which way it should go. So obviously for this bunny, probably the best one is one of these bottom ones. So I'm going to click on that and it automatically positions it, which is pretty awesome. So now that layout is done, let's go to repair. We click on repair and it has said no problems. But you can do things like selecting regions on regions on the bunny if you want to delete them and invert them, separate them. You can crop areas like that, pretty quick. I'm going to undo that. Patch holes. If there were holes in the bunny, you could fix that. Lots of different things. Plane cut, plane cut the bunny like that. Lots of different things. Balance, just to make sure that your model won't fall over if it's unbalanced, that type of thing. But this has no problems, so I'm going to go to supports. So auto supports, I'm going to say optimize rotation. It thinks that the best rotation for supports is this. So it's just going to create a little bit of supports down here and print the rest of the bunny. I'm not going to do that. So I'm going to say auto supports and add supports. They kind of look Meshmixer-y. Right, so going up. But the nice thing about this is it creates really, really beefy ones down at the bottom, and then going up. So this is based on Meshmixer and is kind of uses the same code base, I would think. Now these supports are really, really beefy, and I'll kind of go into what that means later. And then you can do manual supports, so you can go in and add different manual ones down to different places. I have this set to be pretty thick supports, which is why I am unable to create too many of them. But you can see that the line is red. If I could get the line to be green, then it would create them. So it's looking like it's not, my settings aren't going to work for that. But so this is a green line like that. Pretty cool. So then preview, what preview is this actually will create a G-code file for my FDM printer. So toolpaths generated, so estimated volume, 9 cubic centimeters, estimated time, 1 hour, 16 minutes. And you can see literally all of the slices that this will be printing. So this is the path of the extruder going up, has a very kind of low amount of infill. And I'll tell you how to set that later. A low amount of infill, and then it goes up and prints it. So these literally are the toolpaths. So we say export printer file, it will save it as a G-code file. That's pretty awesome. So here's a couple things. Right here, this is set to Series 1. So if you click right under the Autodesk Print Studio, you can say Type A printer. Right now, my Type A machines is not set up. I have a couple of Type A machines in here, but you just add in your printer's IP address for the Type A machines, and it will automatically configure it. The nice thing, let me go back to Print Studio here. The nice thing about this is if my Type A machines were turned on right now, all I would need to do is just click print. It would automatically log into the web interface on the Type A machines, load the G-code file, and start printing. I wouldn't need to do anything. It will actually manage it all from Print Studio, which is pretty neat. Right here, so this is the Series 1, so you can say, create a print file for, there's only a certain number of printers it supports right now. Autodesk Ember, Dremel, Idea Builder, MakerBot Rep 2, the 3 different PrinterBot models, Type A machines, and Ultimaker. More printers are coming, and it's not too hard to set the to add your printer in, but they are going to be adding more printers in, but those are the ones that it supports right now. Right here is the materials, so PLA 1.75 millimeters. I click on this. Let me expand this screen out. So PLA plus, you have different profiles for different materials, best, standard draft. So if I want to enable a raft, I click on this. I can say how much infill I have, what infill pattern, and then advanced settings. There are a ton of settings. Support angle tolerance. A lot of these mimic what is said in Meshmixer, which is pretty cool. Extrusion, extrusion width, all of this stuff. Layer height, how fast you want to print, cooling, all of that things. One thing that I would love to know is where to set the temperature at which to print, which I can't seem to find, but I'm sure it's in there somewhere. But that's something that I submitted a bug on because I can't find the temperature, which is kind of crucial for a lot of stuff. But here's all of the things, right? So when you go into in here, the different layer heights, so 0.2 layer heights, how fast, so cooling, right? So how much, you can slow down your print if you're printing very small areas so your print doesn't heat up. Infill angle, that type of thing, that's pretty, skirts and brims to help your print stick to the print bed. You can put in custom start and end G-code, which is very nice. Raft, what bridging you're doing, and if you have to do priming, another thing for dual extruders and all of that. And under support, you can see that the support structures I have right here, support post radius of 2 millimeters is good, but maybe not for a model this small, right? So this is actually a pretty small little bunny if these things are 2 millimeters. But I wanted to show you what, let's see, go back here. I wanted to show you what Print Studio was because it is a really interesting project that's going on. And for those of you out there who run resin printers, DLP, where it shines a light via projector upwards, Ember, this Print Studio software will create those images for DLP projectors. Before Print Studio came out, the only software out there that you would use to create the slices for a DLP resin printer was Creation Workshop, which is free software. But this is actually very, very advanced type of thing that will create all of those image slices with the support structures that Autodesk uses for their $5,000 printer can be yours also with this free software. And you don't, and so that's really, really cool. So very, very useful for that. And so a question here, Bill asks a couple. How do I like the Type A machines versus the MakerBot or Replicator 2s? So I haven't owned a MakerBot because I did my research and a lot of people were having a lot of problems with the hardware on them. If you look at them, there's a lot of kind of plastic components that over time tend to wear out, and people, at least the ones that I know, have complained about the support that Meshmixer, that MakerBot gives. But then other people I know say that MakerBot gives really good support to its printers. So since I use these printers for my business, I made it on two decisions. One, I didn't want to be in that crowd that might have problems with, a printer that wasn't reliable, because I needed to rely on it for my business. And a big thing is that Type A Machines is here in the San Francisco Bay Area, and I'm able to go down and talk to them, see what their manufacturing techniques are, experience what their tech support is like. And so we have a really, really good relationship with Type A Machines. We resell their printers. We don't sell a whole lot of printers, but they're the only ones that we sell just because some customers ask for them. So I'm sure MakerBot is good, but I just have some worries, especially with the new MakerBots, with the smart extruders. I haven't heard the best things about those, as well as, reviews in Make Magazine and other things that say that there's kind of maybe some issues with that. And so we really like the Type A machines. We've used those for a couple of years now. I have one right there, that prints right behind me when I run print jobs, and I like that. The difference between the Series 1 and Series 1 Pro, the Series 1 Pro is a lot beefier frame, so any of the jiggling of the build plate that can lead to a little bit of waves in the surface pattern are drastically reduced in the Series 1 Pro, and it has a heated build plate. I don't print with anything that needs a heated build plate, so that addition is not something that I need. And I've been able to affect the surface quality of these Type A machines by installing, let me get up for a sec. I replaced these, which are the stepper motors, these are the ones that were in the Series 1 with the silent step sticks. That have essentially make that printer completely silent while it's printing, which also affects the surface quality for the better. So I think I've gotten some good upgrades on my Series 1 that make it Pro-like. And since I really don't need the heated bed, that's probably the most pricey component to the Pro versus the non-Pro. Hopefully that answers your question. So that is pretty much it, I think, for this today. I've had a very packed hour of Meshmixer discussions. Obviously, send me requests for what you want me to talk about in the future webinars. And I think hopefully by the time the next webinar comes out, there'll be some good Meshmixer news and a lot of stuff for us to go over, hopefully. So can't say more than that, but I really hope that that's true. So thank you, everybody. And obviously, my name is Nick, and you can email me at nick@honeypoint3d.com and ask me any questions, with rapid prototyping questions, Meshmixer questions, education questions, anything. So thanks so much, and I will see you around. Bye.